All right. Well, g'day everybody again. So today, this is now our utilities panel, and so I'll just starting with Paul here, get you to introduce yourself and talk a little bit about what you're working on right now, if that's okay.
Okay, thanks, Rob. So I'm Paul Austin. I work for the Australian Energy Market Operator. For those of you who don't know what AEMO is and what we do, we operate the nation's electricity and gas grids, and that includes the Southwest Interconnected System in WA. And we also operate the national electricity market and the various gas markets around the hubs that we have. We're also the system planner for the NEM, and the Integrated System Plan, the ISP, is one of our key documents, which sort of describes what the future might look like under various scenarios, and 2050 being obviously a key scenario to think about. And a more recent role for us, which we just added, is AEMO Services as a subsidiary of AEMO in conjunction with the New South Wales Government, is implementing the New South Wales Electricity Infrastructure Roadmap, or ACT, and that is a process of building 12 gigawatts of renewables and 2 gigawatts of long duration storage by 2030. And so they're conducting auctions for that, and there will be at least 2 auctions a year for the next 10 years to achieve that aim. So we're ranging from actually sort of planning the system in the case of New South Wales, actually delivering the generation infrastructure in conjunction with the transmission infrastructure to deliver towards the targets that have been set.
Tim Nelson from Iberdrola, Australia. Iberdrola is one of the largest clean energy utilities in the world. Here in Australia, we've got around 1 gigawatt of renewables plus some firming assets. So 2 gas-fired peaking units, one in Smithfield here in New South Wales and one at Bolivar in South Australia. We've also got 2 batteries, the Wargrove battery here in Sydney and the Lake Bonnie BESS. So what we effectively do is we retail to C&I customers, not resi and not small business, but we retail to C&I customers providing firm green products. So one of the things that we've seen in the last kind of 5 years is an evolution of what customers want. They don't want run-of-plant PPAs anymore because that exposes them to significant sleeving risk. So in other words, when the wind isn't there and the sun's not there, they have to have a retail contract that kind of deals to those issues. It's much easier if they just put it all into one single contract, which is what we do. So we've got customers, like Woolies, BHP, those types of customers. I look after the energy markets business, and so we're looking at new renewable investments and new firming assets. And one of our, I guess, key opportunities that we see here is not only that renewable side of things, but that firming side of things, new batteries and new firming assets that, for all intents and purposes, look like gas turbines, but don't run on an emissions-intensive source.
Thank you. Dmitry, Danilovich. I'm Director of Development at Acciona Energia. Acciona Energia is a developer, investor, long-term owner and operator of renewable energy assets. We're what's called pure play renewables. So we don't have any fossil fuel generation, pure renewable energy business. Large multinational, we're in 20 countries. We've got about 13 gigawatt of capacity around the world across wind, solar PV, solar thermal, hydro, pumped hydro storage, battery storage, etc. In Australia, we've built and we're operating 5 wind farms. We're currently constructing McIntyre wind farm, which is at 1 gigawatt, going to be the largest in Australia when it's going to be completed. And hopefully by the end of the year, we'll start construction of a large-scale solar farm around 0.5 gigawatt. So quite a large portfolio, growing portfolio, looking to do more renewables.
Wonderful, thank you. All right, now we did actually have a pre-game discussion about what we were going to talk about, but that was last month during reporting season, so I have actually no recollection of that conversation at this point. Maybe can I ask you an open question about how you're thinking about your business configuration, be it customer focused, be it development focused, or Paul, in your case, how you're going to be changing the rules on us in the next little while, given the challenges and opportunities that you've talked about. Maybe start with Paul.
Well, we don't change the rules. That's the AEMC. But in terms of what we're focused on, I mean, there's obviously many facets to the energy transition, and the numbers are huge. I mean, we're looking at the ISP saying we need 30 times as much storage as we have today. We need 9 times as much variable renewable energy, wind and solar, 5 times as much distributed solar. And the forecast for 2050 in the ISP step change will be for energy consumption to double. And that's after the last sort of 6 or 7 years being in sort of general decline in terms of energy consumption in the NEM. And where AEMO is obviously producing these forecasts of what the grid needs to look like, our sort of main concerns are around things like storage and firming. And we heard from the previous discussion, the reliability sort of issue, what will be there when the wind is there, when the wind isn't there and the sun's not shining. And this is obviously very top of mind for AEMO, and we're very much advocating for medium to long duration storage as being something that we need to be pursuing. And that is a key part of the New South Wales roadmap, is identifying the sort of long duration storage needs. And they have this 2 gigawatt target, and it's made up of both batteries and pumped hydro with 2 different types of sort of contract structure to underpin those investments. The other area is gas, and you might have heard about the gas statement of opportunities that came out today, and that sort of flags the risk of gas sort of not being there at different times. And this is obviously a key issue with gas transitioning and potentially declining over time. How do you sort of run down the gas system and replace it with electricity while still encouraging producers to actually supply the gas at a reasonable price, and gas transmission companies to make the necessary investments potentially for a smaller sort of usage base than they currently sort of serve. So that's certainly a key challenge as well.
I guess that the key challenge is just really the rate of change, because it is such a rapid, investment opportunity. So that kind of really does open up a whole bunch of questions in and around, just social license. So making sure that we're doing the right thing by communities and customers. I guess the 2 things that I'd probably talk to there, one is that customers aren't all the same. So if I put on my research hat, I've got a role as an associate professor up at Griffith Uni. I do a lot of thinking about the heterogeneous nature of residential consumers. When we talk about looking after consumers, we can't just think about looking after the average consumer. We have to look after all consumers. And I guess the thing that I find in the energy transition is that the biggest barrier to participating in it is owning your own home. If you don't own your own home, you can't put solar PV on the roof at the moment. You can, but it is such a hard thing to do that you don't get around to doing it. So this social license issue is not just, we've got to look after people in regional areas who are impacted by the energy transition. It's looking after all kinds of different people through society. And I think the industry's got to do a better job of working out that it's not just a uniform approach, it's actually a very differentiated approach where you are. I guess the second thing that I'd point to that is kind of a great opportunity as well, but something that that we're doing a lot of thinking of, certainly at Iberdrola Australia, is thinking through, we definitely need to invest in pumped hydro, and we definitely need to invest in batteries as an industry, but we also need to develop that next generation of technology that can go for a lot longer than pumped hydro during prolonged periods of renewable drought effectively. So in a paper we had published in the Energy Journal, what we did is we tried to think of, well, how can we come up with a proxy for what that might look like? So we included fuel as an option, in a least cost modelling exercise at $55 a gigajoule. And we included some extra capex for the turbines. And we still found that the least cost optimisation was building 8 gigs of these turbines. So we need to work with the OEMs, we need to work with governments to try and develop that next generation of technology. And I think it's great the Commonwealth is working with Snowy, for instance, on what they can do. We're certainly working with CS Energy and the Queensland Government around what we can do to develop that clean technology, whether it's hydrogen or whether it's green methanol, something that effectively has that zero emissions footprint, but can be stored and therefore can get you through those longer periods.
I'll come back to a question, Rob. Development focused versus customer focused. Both. We're development focused, we're customer focused, we're also grid focused. Yes, development is bread and butter. Of course, we're focusing on developing our portfolio of renewable energy projects, turning them into renewable energy assets. Definitely customer focused. There is no point building generation capacity if there isn't a customer for that offtake. But also grid focused. Connection to electricity transmission networks in Australia has become very challenging. Grid is constrained. Grid is not handling the amount of renewables that's coming online or wishing to come online. I can only echo comments made by the speaker in the previous panel about the complexities of connecting to the grid. So having worked in renewables for close to 15 years now, it's kind of shifted from where the best wind resource or solar resource is to where can you connect. And if you can connect there, the engineering department figure out how you're going to extract wind out of that resource. Whether there is wind there or not, that's the point where I'm connecting.
All right, thank you. Now, bearing in mind we have a global listed infrastructure audience today, and I'm pretty sure all of you have international experience of a kind, and two of you work for big global companies. Can you talk to anywhere in the world where you see some good ideas that that people, regulatory or company, could adopt?
Well, I'll start perhaps. As I said, Acciona operates in about 20 countries, and we catch up as a global senior management team on a regular basis. In the last couple of years, virtually, but finally in person. And having just recently attended our senior management meeting in Madrid, it was a good opportunity to exchange ideas and see what other countries are doing and promoting renewables. The tax equity mechanism in the United States does work. Whatever we think about efficiency of capital allocation, et cetera, it does work. It does attract investment. So I wish we had a similar structure whereby developers get preferential taxation treatment for projects that are renewable.
I'd probably point to contestable transmission. I think that in an environment where you've got to move quickly, contestable transmission does seem to work. And I know Iberdrola's experience globally there, both in the UK and then through Latin America and into Brazil, contestable transmission is seen to actually deliver transmission more quickly and I guess at lower cost. So in the transmission space, I guess that's one observation, that contestability tends to kind of work. The second observation, though, that I'd make is probably in and around Iberdrola globally, but also locally experience in and around CFD frameworks. CFDs are increasingly creating real problems for industrial customers because they mop up all of the green energy out of the market. Government becomes a single counterparty risk. And effectively, customers can't get access to the green energy. So if you look at some of the outcomes in Europe recently, you're effectively getting customers going into those saying, well, we just want the green energy because, as the previous panel pointed out, we need to demonstrate to our stakeholders that we're buying green energy, we're decarbonising our own businesses. There is a real question mark around the sustainability of CFD frameworks. In the New South Wales context, you've got to give them credit for at least trying to pivot away from that with this idea of swaptions. But again, it's really important that governments keep focusing on how they make sure that those frameworks ensure that companies that should be wearing the risk of their investments are effectively managing those risks, not effectively handing them back over to government.
And my observation would be a focus on energy efficiency, and certainly energy efficiency is the number one thing to do because you get paid for it, and it also helps to lower carbon emissions over time. So when you look at places like Europe and building standards and standards on vehicles, much higher than they are here, and a greater willingness for people and potentially related to generally higher costs of energy, but a greater willingness for people to try and save energy and make their homes energy efficient. So I think there's something we can learn from there.
Great. Well, now let's open up to the floor for questions. If anyone has any. Yeah, right here in the front.
I've got Rick Walters from Aware Super. I've got a question for Tim. Your specific comment on long duration storage. I was a bit surprised by your comments on pumped hydro. I thought ANU and others had shown clearly that there was plenty of pumped hydro in Australia and it could fulfill those long duration storage needs. But so can you just elaborate on that a little bit more about where it falls down?
So we definitely need pumped hydro, but we need a mix of technologies, and the optimal mix is probably something along the lines of 40% short duration storage, so I think batteries, 40% long duration storage, which is pumped hydro, and then 20% this technology that can go days on end. And what our modelling found, funnily enough, is that it's least cost to actually charge the batteries using these clean fuel turbines rather than overbuild the turbine. So you could overbuild pumped hydro, there's no doubt about that, but it would come at a prohibitively kind of high.
So it's a cost issue rather than anything else. Okay.
Yeah.
Thanks.
I think there's another dimension to it. Well, I'd agree with Tim that you don't want to overbuild, and previous studies like the ENA did one have shown that the optimal mix is not to have everything in storage. The other thing is the correlation. So when you need hydrogen, for instance, is when your wind and solar is not going to be providing the electricity to the grid. And then we could find ourselves in some interesting issues where hydrogen exports are competing with domestic use of hydrogen and replaying this sort of current issue that we have with the gas
water issues
world.
as well, I guess, is the other one.
I guess I would also add that you can't look at the technology mix in isolation of the grid and interconnection with neighboring regions. In Europe, what we're finding is there's a lot less focus on battery storage or pumped hydro storage than what you have in Australia because of the interconnected networks, and there's actually robustness in the networks with generation distributed throughout large areas with resources that are not sort of concentrated in the same region with the dependence on the same wind resource, solar resource. In Australia, with limited interconnection, we're facing a very different dilemma.
Interestingly, none of you have mentioned offshore wind. And at the moment in Australia, there is a bit of a land grab going on. But it seems some of the issues you have raised, such as connectivity, such as transmission contestability, really would manifest, if Australia is to get their offshore renewable off the ground. How are you thinking about it? And is this just a white elephant, or will we actually have offshore wind in Australia?
Well, in terms of AEMO's ISP, there's no offshore wind in the ISP. That doesn't mean that it shouldn't happen. And the challenge for offshore wind is obviously it's more expensive, but it has some certain advantages and depends on the location of the offshore, obviously, but Bass Strait has some advantages in terms of diversity of wind resource and good connection to the transmission system. And connection to the transmission system and building new transmission is obviously a key issue, as our last sort of panel talked about. And so there could be certainly some merits in offshore wind in that sort of future energy mix.
The thing that I'd add is the Victorian government's made it very clear that they want to build offshore wind, and I'm sure I speak for probably every kind of developer in the kind of country that we'll pin our ears back and try and kind of meet those requirements. For those that haven't seen it, there is this wonderful website you've got to look at called windy.com. So I'd encourage you all, if you're just wanting to have a really simple explanation of where it makes sense to build wind, windy.com gives a real-time, there's a map, and you can see anywhere in the world whether it's windy or not. And what I would say is that the capacity factors you get from offshore are things that, as an energy markets guy, you can only dream of. They're generally pretty consistent, much, much higher, much easier to bring into a portfolio. Because what I try to do for Iberdrola Australia, you try and get as many renewable resources as you can from different parts of the grid that have different profiles. And that allows you to build a portfolio and determine probabilistically how much firming you need so that you can kind of then sell firm to customers. Offshore wind, yes, it is more expensive. There's no doubt about that, but it provides some stability because of those high capacity factors. Then it just comes down to a cost kind of benefit trade-off. But yeah, certainly governments seem to be pivoting towards it, and kind of to the extent that it's a race. Everyone's happy to race.
There's definitely a role for offshore wind in the energy mix. But I guess you got to ask yourself a question: why would you go offshore? Either because you don't have the resource onshore or the land where to put your wind developments onshore, which is the case in many countries in Europe, or the generation output of your offshore wind farm is actually complementary with the generation sources you've got onshore, your onshore wind, your onshore solar PV, or you've lost a social license to build onshore. So we're going to be very careful with community perceptions of overbuild of wind capacity onshore to maintain that social license. But yeah, I echo the comments made by the speakers on this panel. There's definitely a role for offshore wind where it fits into the market.
Georgia?
Apologies if this is a bit of a meaty question, but maybe Tim and Paul, you can share your insights from the Australian perspective, and Dmitry chime in on the European perspective. But there have been lots of challenges around financeability and cost allocation for interregional interconnectors. And for instance, in Australia, we saw the issues related to Project Energy Connect and Marinus Link. And these issues also permeate other markets such as Europe and the US. What's the sort of future hold for the review around financeability and cost allocation for these critical infrastructure projects that need to connect up the renewables?
Well, obviously, AEMO supports sort of further investment in interconnectors, and that's the output from the integrated system plan is recommendations to enhance interconnection. And we also have been very focused on actionable ISP projects, so actually getting these things done and accelerating the current process, which goes through the AER, which is called the RIT process. Merchant interconnectors versus regulated interconnectors. Well, we've had merchant interconnectors in the past. We've still got Basslink. That may not stay in the merchant sort of category. So it seems that it's going to have to be done through regulated interconnectors, and some sort of financial support I would expect is required. And rewiring the nation is certainly one of the vehicles for providing that financial support.
I mean, the thing that I'd add, so I think it's a really good question, because when interconnectors are built, the way that they're funded by the different parties on either side of the border isn't necessarily who benefits the most. And I say isn't necessarily who, because sometimes it is. But I think that the critical things for me are, if there is a gap between what we think that consumers should be paying for an interconnection versus what we think the longer term benefits are likely to be, because whenever you're building interconnection, you're taking a 30-year view on what the market looks like. And by definition, we're all going to be wrong. It's just a case of, evolving over time, whether we were very wrong or, actually things are a lot better off than what we thought they would be. And if there's a gap, that's where things like rewiring the nation are actually really useful. So, having funds that are available to de-risk projects, and then also to kind of allow the AER to think through a little bit more, I guess, socially minded, what some of those TUOS costs on either side of the border need to be to fund the thing in the first place.
Broadening the question from interstate interconnectors to generally funding of transmission infrastructure, it's always a fascinating debate. But at the end of the day, who's going to pay for it? All of us are going to pay for it, either as electricity consumers or taxpayers. It either goes through government funding and we pick up the bill as a taxpayer, or it goes through funding by the electricity industry and we pick up the bill as a consumer. The question is, how do you fund them and how do you deliver them in a timely fashion, and how do you fund them more efficiently? We're a renewable energy developer. We would be happy to fund connection of our assets and upgrades of infrastructure. We're ready to fund it, but we need a level playing field. When you have a scenario where one renewable energy developer gets regulated access and the other renewable energy developer has to pay for the access, there's not a level playing field. There's not a fair competition on the levelized cost of electricity. So the governments need to be cognizant of creating that level playing field. New South Wales government is trying to do that with the Arana renewable energy zone, where access will be tendered to renewable energy generators. So we'll see how that process goes, and maybe that's a suitable model.
One thing I would add, though, is that governments have increasingly got to be aware of the consequences for social equity in using the electricity bill to fund public goods. The nature of the way in which households use electricity relative to their income means that every unit of cost you add onto the network component has a disproportionate impact on lower income households than higher income households. And over time, that's leading to an increased burden on the very people who can't afford some of the transformational things like a solar PV system, a battery, those types of things. So governments have really got to be thoughtful in how they use the electricity bill for some of that stuff.
We've talked a lot about upstream activity, renewable energy and transmission, so forth. What about downstream, particularly as it relates to electric vehicles? We thought about, in terms of market design or network design, what the increased load will be from electric vehicle demand longer term, and if that load ends up being two-way, how you might need to transform the network.
Yeah, and it's a good question, and certainly it's part of the way the ISP is modelled, and a good part of the reason why the electricity consumption doubles by 2050 is to do with extra load coming from electric vehicles, and they are obviously a movable battery, so they have advantages if they can be coordinated. And so AEMO has a number of projects that we're involved in terms of how do we improve the coordination of customer energy resources, and what is the standards and what are the rule frameworks, and we're doing that as part of the Energy Security Board's initiatives. I mean, one thing that we've certainly commented on in the past is around sort of when you charge your electric vehicles, and the best time to charge them is middle of the day when the sun's out and there's potentially surplus energy which is going to be curtailed. And so how do you put in place the policy frameworks and the support to encourage sort of charging during the day? When we used to go into offices and do our work, you could put chargers in sort of offices. It's becoming a bit more complicated now. So these are definitely policy questions to be worked through. Pricing regimes to encourage that is another option, but the history in Australia of applying pricing regimes and multi-part pricing is that consumers find it too complicated to compare between different pricing regimes. So you almost need to sort of separate out the electric vehicle load and have that on a separate sort of arrangement, really.
I actually think this is amazing opportunity for networks. So, not being in the network space, I can kind of somewhat give an objective view here. But anyway, so at the moment, the average household's using roughly 5.5 megawatt hours kind of, throughout the NEM, different in different regions. But we got the sequencing wrong. So we all put in air conditioning in the early kind of 2000s, then we went and put PV in. And so the capacity factor or the utilization of the network fell materially throughout kind of the last 15 years because there's so much PV, more energy efficiency. If we were to all completely electrify our homes, so electrify your transport, make sure that we weren't using gas for hot water, those things, you'd probably lift that 5.5 to something like 10 to 13 megawatt hours a year. But because the capacity utilization in various parts of the distribution network is so low, if you use that extra energy at times that don't contribute to peak demand, it has this rare effect of creating a positive benefit for everybody because we use average cost throughput pricing, dollars per megawatt hour rather than dollars per megawatt. So I think if you go back to the early literature, it was all around price, kind of cost reflective signals. You get all of these kind of movements. And it was probably ahead of its time because consumers didn't have the automation tools that they've got now that you can install in your home to say, well, only turn that on now. And there's an algorithm that kind of does all that for you. So again, networks have this amazing opportunity. If they start thinking about how to do this well, I think that they could see some serious improvements, not just to the bottom line, but to consumer outcomes. And I guess the free advice I give to every network is if you've got electric off-peak hot water and you've got a problem at the moment with solar exports in the middle of the day, give every home that's using electric off-peak hot water a heat pump for free. Because all of a sudden, you reduce the kind of impact on your network at night and you soak up all that solar in the middle of the day. There's just little simple things. And once we get to EVs, then you've got an even bigger opportunity.
I tend to think about electric vehicles not just as a load, not just as consumption of electricity, but also as a source of energy. With smart electronics, your electric vehicle plugged in your garage can actually discharge electricity back into the grid. And once we get to the level of penetration of electric vehicles that is sufficient to create meaningful input back to the grid, that will really help to take volatility out of the electricity market. Because when you're at home and you've cranked up all your air conditioning systems and the demand for electricity has gone up, that can be partially offset by your vehicle discharging power back into the grid. And then the smart electronics will recharge your vehicle in the middle of the night.
How many years away is that?
Oh, that's an interesting question. It really depends on what incentives government offers to users to buy electric vehicles, because at the moment, they're, as we all know, they're considerably more expensive than petrol or diesel vehicles.
And we shouldn't forget it takes 3 tons of CO2 to make a battery. So using things for longer and being efficient is always a good thing to do first.
Any other questions? Maybe I'll jump in while we're talking about downstream and distributed energy systems, and thoughts on virtual power plants and the application of AI in that kind of a setting to start with.
I mean, I guess I'll kind of open up with, because we've got a couple of large-scale BESS, you know, we're already in the situation where the spot traders in our trading room are monitoring what the batteries are doing, but the batteries are largely trying to co-optimize across 9 markets, which requires a lot of, whether it's AI or algorithms, I always get confused, Rob, but yeah, it's technology. So we're already...
Depends what multiple you want.
What's that?
Depends what multiple you want.
Well, yeah. So I think there's already that kind of thinking that's gone on in the large scale space. In the small scale space, it really comes down to the transactions cost. So can you overcome the inertia that goes with whether it's households or small businesses giving up control of their device, whether it be a battery or something consuming energy? Because that's not an economic decision on its own. It's also an emotional, it's a decision that the household has to make. So we're looking at a whole bunch of VPP opportunities, but more with our commercial customers that have got sites in many different parts of the grid. But again, they tend to be larger opportunities with smaller numbers of customers rather than relying upon, you know, 1 million households, for instance.
Just following up on your comment, Tim, virtual power plants, and again, back to electric vehicles. Virtual power plants are obviously a great source of power supply back to the grid. The question is whether we as consumers are prepared to give up the flexibility that we're accustomed to. So if it's 11 o'clock in the evening, you suddenly decide that you want an ice cream and you want to go to a local shop to buy that ice cream, your electric car parked in your garage is fully discharged because you haven't gone out at 11 o'clock at night in the last 365 days in the last year, and the electric and the smart electronics knows that it can discharge your vehicle. If you're prepared to give up the flexibility, there are benefits obviously for the network and there are benefits for the consumer, but don't change your patterns of behavior. The electronics is not going to adapt to that.
No, it's fine.
Yeah, up the front here. I think you'll get a drone to deliver that ice cream to you.
Go out on your bicycle's the answer. On the issue of investors, there's some areas that investors are investing in and it's very straightforward. There's some areas the government is doing the job and that's fairly straightforward. There's a big space in the middle, which is very confusing and different in different states and all kinds of things. Where do you think all of us as investors should be focusing and where are the best opportunities? Not the obvious ones, I mean, but the ones in that middle ground, and where should it's really government's job to invest and to subsidise and to whatever, and how do you play that as investors? We're all investors trying to figure this out. How do we best play our role, I guess, and where do we target our funds?
That's a big question.
It is a big question. I mean, you're right. I mean, if you look at wind and solar, grid scale wind and solar, that's there's a lot of money looking for a home, a sustainable finance, driving these sort of clean investments in renewables, and obviously that then has a flow through into their cost of capital. So we have seen a huge amount of investment in renewable energy, but it's becoming more complicated. The more you build, the more the sort of grid impacts need to be considered, and you need to worry about marginal loss factors and your coefficients in the dispatch engine and these sorts of things. So we're seeing investors sort of becoming more attuned to these risks now. When you look at the sort of reliability side of things, it seems to be moving much more towards government driving that. And we've seen the capacity mechanism, which I was involved in last year, sort of be taken over by the Commonwealth Government, and now they're putting together their own scheme, which will be aiming to promote that. And we've got a similar sort of arrangement in New South Wales, where driving sort of investment in capacity. So the role of the market in driving that through the market price cap and the signal there seems to be being diminished and being replaced by sort of governments really stepping in, because they are more worried about the reliability sort of impacts. And then transmission, I think, sort of probably falls into the same category, where rewiring the nation and other initiatives like that, big complex transmission projects are hard sort of to get across the line, and so they need government support to make them happen and push through all these issues around the sort of the environmental and social impacts of new transmission lines.
And the other thing I'd add is probably electrification. So overcoming transactions costs is something that the industry's always really struggled with. How do you actually, because, you know, intuitively it makes so much sense to do so many things that we've all spoken about on the, particularly at the demand side end, and yet year after year we all talk about the fact that it doesn't happen. I think that's where I would say there probably is the greatest opportunity that's never been tapped. And I keep coming back to that example of, you know, in the Ausgrid patch, pretty much exactly the amount of solar exports every day is the amount of off-peak hot water consumption overnight. And so it's just sitting there, and we're all looking at it saying, well, that should kind of prompt some action. Nothing ever happens. So I think whoever it is that can come up with a business model that overcomes some of those, that inertia that prevents customers taking advantage of some of the dynamics of the market, subject to being able to get their ice cream, I think that's really where I see the industry has not really been able to kind of deliver, and that might be where there's an opportunity.
You've asked a really good question. How can you as investors accelerate the deployment of renewable energy sources? Obviously, as a renewable energy company, we welcome your investment in projects, in transmission infrastructure to deliver those electrons to the market. But more importantly, in your investment in the broader large commercial industrial businesses, other infrastructure projects, your focus on whether those companies are procuring renewable energy. Because ultimately, it's the uptake of renewables by the corporate Australia that's going to drive accelerated deployment. So if that's one of the key criteria for you to invest in the business, they'll get the message, because that's what's demanded by their stakeholders and investors.
It sounds like you need a high-functioning and analytical capability in that team, ideally with some ESG experience. Anyone else got a question? All right, we're kind of at our time now, so I'd just like to thank our panel members for their valuable insights and time, and if you could thank our speakers while we get set up for our next one.